Well, good evening, everybody. It's 7 o'clock. Let's get started.
We are recording.
Welcome, everybody, to the December 2021 monthly meeting of the Minnesota Astronomical Society. I am the president of the MAS. My name is Mark Jobe. I'll be your MC tonight. How's that?
Your host.
Thanks, Trina. Here's a list of the board members. And here is our images with our names. And one of these faces is changing next month. Stay tuned. So welcome. I want to welcome all new members. This is the list of members that I got from Steve's report. I know there's some others because he said there is others, but that's okay. That's what I captured, and hopefully I captured the rest of those, and we'll introduce them next week or next month. And welcome. This, I will tell you, new members, that you will get as much out of this club as you want. As much as you ask, as much as you want to be involved. And I guess the other piece of that is I like to approach new members and say, hey, it'd be great if we had some more volunteers in many capacities. There's lots of opportunities to help out the club and make this club better. So I encourage new members to do that. And you don't have to be an expert on anything that you're going to volunteer for, because probably somewhere next to you or in your group there is somebody there that would be able to step right in and answer any question, or help you out or give you guidance to get you going. So that's all I'll say on that. This month is December, so that means we have to elect 3 new members to the board. Waltz, I know you're on. I heard you a little bit ago. You want to talk us through this process of how we're going to vote?
All right, thank you. We have 3 positions up for election. That is vice president, treasurer, and one of the board members at large. There is 2 ways to cast your ballot. The ballots, the URL on the screen, the tinyurl.com/2021 MAS election is the URL, and that sends you to a ballot form online. Otherwise, if you don't want to do it that way, you can send an email to vicepresident@mnastro.org, and I will record your ballot. So we are keeping the ballots open for 1 week. So the results will be posted Thursday, December 9th. But as you will soon find out, there is, it'll be a slam dunk. So it shouldn't take too long, but this is just the official per our Constitution. This is what we have to do. And this is how we've done it now for 2 years because of COVID. And it worked out pretty well last year. So please go ahead and click and vote, or send an email to me and vote.
Thank you, Waltz. So speaking of candidates, I'd like to have each of the candidates, John, Matt, and Conrad, open up your mic. And let's have a little order. So John, if you're on, open up your mic and introduce yourself, and the floor is yours. You can have at least 90 seconds.
Well, whole 90 seconds.
Yeah, sure. Yeah.
Okay, I just opened up, so hopefully everyone can see me.
Yep, I see you and hear you.
Excellent. Okay, well, I've been a member of the organization now for several years. If you all went out in the discussion forums, you could see my short bio and why I decided to put my name in the hat for the vice president position. And it just basically comes down to this organization has done for me as Mark, you said to the new members that you can go where you want to with this organization. The people in the organization are fantastic. I was actually, that's the thing that impressed me the most. I had just some expectations when I joined this organization that there'd just be people with knowledge that I could tap into for resources, but I was overwhelmed at the resources, just the knowledge within this organization. And not only that, but the facilities that this organization has and how well it's been run. And once again, referring back to my write-up, is I first saw an advertisement in ENW Optical when I built my first telescope. That would have been 1972. And for an astronomical organization that was just starting. Well, that became Minnesota Astronomical Society. And so it's really kind of an interesting path after several years of being away. I was in the Air Force for a while, and so I was out of state and moved back, and it was actually heading into the eclipse in 2017. A few years before that, I thought that I'd tap into this organization to get more information about that, and yeah, it's far exceeded my expectations. And so I just thought, well, it's time to help out the organization that's helped me so much. So that's it. I don't want to take over the meeting. So if anybody has any questions, go ahead.
You'll get your opportunity.
Okay.
Okay, Matt.
Hey.
Matt, you're next.
Yeah, I am here. Matt Dunham. I've been a member since 2018. I've known about the club for quite a few years through Ron Schmidt as a buddy, but I was busy with other things like Boy Scout leadership and stuff, and I just was not able to do that. But when that period of time ended, then I thought I need to do something else, and I really love the astronomy stuff and got hooked up again in 2018. And I was basically, enjoying the club, and I get to know a few of the people in the club, and a lot of the leadership was really friendly, very engaging. And I thought, well, maybe there's ways I can help out around here. So I was talking to him, and one of the positions for board member at large opened up. So I did that for 1 year, and then in the middle of my term for that, the election came along, and the position for treasurer opened up and needed somebody in there. And I thought, well, I'd be happy to do that as well. And I thought this is additionally, it's a great way to get to know how the organization is operating and be able to help facilitate it and all that kind of stuff. So I've been doing that for 2 years, and I'd like to continue. The things that I enjoy doing the most in the club right now have been hitting the beginner special interest group meetings and things like that. I really enjoy working with, originally Boy Scouts and youth and stuff like that. But any new to astronomy, I like to kind of help get them off to a good start. And often that can be a real challenge for people if they get a telescope. And I've seen this over and over again. It's just kind of just up to it first, and it helps to have somebody kind of give you some of the basics and make sure the things, put together right and tuned up right so you can actually enjoy it. So that's, I think, the thing I do in the camaraderie with the other board members and other team leaders and people in general who are regulars, encourage people to get involved in the facilities and equipment that we've got here. And I'd like to continue for the next 2 years. Thank you very much.
Thanks, Matt. Conrad, if you're on, I know you're on. I heard you a little bit ago, or I heard you were on. So you could open up your mic and give yourself an intro.
Can you hear me?
Yeah, your mic was muted, wasn't it?
Yeah, it was. I'm not sure. Can you guys see me, or I don't know?
Yeah, I can see you and hear you.
Okay. So yeah, I'm losing track of time. Seems like I believe that I started this hobby in 2018. So it's been 4 or 5 years, and the way I got started is I'm not sure if Mike Lynch is on, but I have to give him some credit because I read the Sunday Pioneer Press, and he's got a column in there about astronomy. And after reading that article that 4 or 5 years ago, I told my wife, I said, I think I found my thing I want to do when I retire. I've got about another year or two to retire, and I wanted something that's going to keep me busy. So I decided to get into it and then start working with Starzona with my first telescope. Developed a really good relationship with them, and I absolutely love the hobby. I'm passionate about it. I would never thought I'd be where I am today. I started out doing visual. Had no interest in doing anything with imaging, but the bug caught me after seeing what everybody's doing in the club imagers. And so then I started to make the leap into planetary imaging. And then I moved on to deep sky, and I absolutely love it. So I enjoy being board member at large. Some of the tasks I've done, I worked with Joe Timmerman's sale of his equipment. That was challenging, but I was up to that. And I just like helping out and working with, I like the association with all the other members of the club and learning more. And so that's kind of why I'm running. So I love astronomy. That's about all I have to say.
Well, thank you, Conrad.
All
Thank
right.
you. That's good. That's what we want to hear. So everybody, go find your ballots and pull the lever, and let's get the new board assembled. And I look forward to working with the new board.
Hey, I got a question.
Okay, Dave Faulkner, question.
Is there going to be like a link on the main page or something to voting?
I don't.
There's a
think so.
link from the forum, from the
The forum.
announcement
Oh.
section in the forum. There is a link.
Okay.
It's the
All
same
right.
link that was shown. So
right.
yeah, there is.
All right. I just want to know where to find the link. Okay. Thanks.
Yep.
I guess that's a good point. So either you got it off the slide, which will be, the slides will be posted and the video will be posted as soon as I get it processed. And then there's the link from the forums. I think that's the two places that it'll be. So let's move on. So just to let everybody know that year-end donations, we know that some people have kind of saved their donations till the end of the year, and they do donations to different organizations, and we would like to be one of those organizations. And just to let everybody know that's doing those types of donations, is that donations outside the normal membership dues are matched by our anonymous benefactor up to $10,000. Now, some of you that are just regular members might want to consider stepping up and becoming a patron member, and that extra little kick in a donation is qualifies for the to be matched by the benefactor. So and then I mean, there are a lot of generous people out there that just write us a check, and it's a donation, and we're very appreciative to those people, because those people and the patron members and and the regular members too, I'm not going to discount anything about that, but that's what keeps this club running. We run it all on volunteers, but like like Conrad said, and Matt said, and John said the same thing, is that, you know, we have a lot of equipment. We have Cherry Grove, which is our property. We own that. We own that little postage stamp size piece of land. You know, all that takes money to maintain. I believe we have, we don't have taxes to pay, but we have utilities and things like that at all the various sites. So that's how we, you know, that's how we maintain it, is through that money. So thank you very much to everybody that pays membership, and our patron members, and our just donors. Thank you very much. Speaking of that, Waltz, you have a special announcement.
Yeah, a special announcement. This is, as most people are aware, you know, our longtime member, founding member, Lauren Nelson, of our club, founding member of our club, passed away. And, you know, we had a memorial for that earlier in the year. But Lauren's family, with the facilitation of also sometime member Jeff Brown, they have generously donated a lot of Lauren's equipment to the club, and to do as the club sees fit. So what the board has elected to do is to donate a lot of the equipment and give it to the members. So we're going to put books and small value items. We're going to give those out at our first face-to-face meeting, which I hope Mark will soon talk about. And we will, starting next week, put out on the forum a lot of his equipment, including some telescopes, including a C14, a lot of camera gear, eyepieces, and that kind of stuff for on the marketplace next week. So similar to what Conrad facilitated with Joe Timmerman's gear, and all of the revenue generated from those items will be go to the MAS General Fund. So we thank the family of Lauren for doing this. You know, Mark and I and a few others went over to his house last month and helped kind of clear it out and clean it and evaluate some of the equipment. So some of that equipment will be offered for sale starting next week, and I'll post that onto the marketplace forum then. So any questions, you can certainly reply on the forum or reply to Vice President at mnastro.com. Thanks.
Actually, it's mnastro.org.
.org, that's correct.
All right, thanks, Waltz. I'd like to take just a minute just to thank anybody that does volunteering. In this particular month, I want to shine the spotlight on all the leaders, all the people that lead and are part of committees for the various sites, LLCC, CGO, ELO, JJC, Metcalf. You know, if there weren't committees and members and leaders in those places, you know, people would show up in there and go, you know, this place is kind of a dive. You know, I don't think I'm coming back. I don't think I want to be a member any longer. But I'll tell you that, you know, I know, and I've been to all the sites, not recently, but I've been, you know, I haven't been to JJC in a few years, but I know what's there, and it's top-notch stuff. Again, speaking to the new members, if you get an opportunity to, well, JJC is probably the one that you have to wait and become a key holder, but everywhere else, if you get an opportunity to attend a function or attend a ISP, impromptu star party at any of the sites, do it. Find out more, find out what it's about. It's incredible. And then there's, I want to thank the volunteers for the November BSIG, Suresh and Dave Tosteson, and people behind the scenes that got that thing recorded and processed and up on the YouTube. You know, thank you for that. And then I know that there's work being done on the website, and it might not be moving as fast as we want, but we'll get it there. And then I know the last star party occurred at ELO in November. So again, thank you to all those people that worked that star party. And now a brief timeout for a help wanted ad. I guess Waltz, I got to put you on the spot again. Okay, maybe not. Waltz has been working. Waltz has been heading up the.
Sorry, I was on, so I couldn't find my mute button. Yeah, so we are making progress. I think as I am my term on the board as vice president, I am stepping down at the end of my term at the end of the month. So my commitment is to concentrate full time on the new website and to get this done. So that's how I'm going to keep going.
Terrific. Thank you, Waltz. Yes. And I've seen parts of it. I've kind of been in there. I was tinkering around in there. Not too much. I don't think it's too visible, but I was there. It's going to be great. New calendar. That's going to be the most important, most exciting place for as far as I can see. And then obviously that it's going to work very well on mobile devices. So, good job. And then breaking news. Our next meeting will be a hybrid meeting at Fairview Community Center. It's at the same place, but you won't be able to park where you used to park. You'll have to, and just kind of, I was looking for a map, but Google Map has not been updated yet. So when you arrive to the same driveways that you used to come into the parking lot, you actually won't want to go in there. You'll want to go to the far west end of the building and take that driveway there. And what that's going to do is lead you around to the south side of the building. So the image that I have on this slide is the south side of the building. And those 4 doors that you see are the doors that you'll be able to go through. Those are the only 4 doors which will get you to the meeting room. And once you come into that foyer, there will be a person that's most likely going to ask you, why are you here? And you're going to basically tell them that you're part of the MAS and you're on your way to the meeting.
Can I ask a quick question about that?
They'll buzz you through. Yes, Suresh.
Is there enough parking like there used to be in the past?
There is plenty. There is plenty of parking. We will not use half that parking lot.
Lots.
Excellent.
There's tons of parking lot. So there's nothing there. There's plenty of room. Don't worry. And even when I was there on Tuesday and it was in full session, the parking lot wasn't half full. So if we come and there's still people there, there's still going to be plenty of room.
It's all flat and accessible too. It's fairly close.
It's wonderful. So anyway, so those are the doors you're going to go through. The other details are that everyone, regardless of your vaccination status, will be required to mask. That's our rule, but it's also Fairview's rule, is that if you're going to be in the building, you're going to wear a mask. The MAS is no longer going to provide snacks or refreshments, and that's a board decision. But you can bring your own. If you want to bring yourself a little sack lunch, you certainly are welcome to do that. You can bring coffee and water. We specifically asked them about that. They're fine. Of course, pretend you're in your own living room and take care of your spills. That's the way I see it. Just be careful. We are their guests, so we have to treat it like that. And from my understanding, the room that we're meeting in is on the 2nd floor. I've been in that room. To me, it's huge. To me, it's bigger than the old room. I think it's got great capacity. I believe we're going to use the whole space. It has the ability that it could be split into 2. I mean, if we start seeing that we're not going to use the full space, that people aren't showing up to be to the face-to-face part, then we'll drop down and we'll use half the room. But there's 2,500 square feet. There's no reason why we couldn't get 120 people in there around tables. Not so much around tables. They're going to set it up for us so that there's basically 2 persons, 2 chairs per table. There should be plenty of room for us to spread out if we want to spread out, and it should be great. And then we're also going to maintain the Zoom meeting, so we will broadcast live from that room. So that's for some of you that choose not to attend the meeting face to face, you will still have that option. It'll still be recorded. It'll still be put up on YouTube. We'll continue to do that. So with that in mind, I have a request. I'm looking for an audio visual manager, and it's the title there is probably a little more frightening than actually what the tasks are going to be. It's only for the face-to-face meeting. Looking for somebody to just help out, man the computer that is connected to the room, basically, to handle all the audio and because there's audio that's going to be coming from several places. The people that are on Zoom, the audio from inside the room from people that are not presenting, and then obviously the presenter, whether it's me or our special guest, or it's somebody that's doing a special presentation. It's just managing that audio, and so we have another session there, and whoever that person is, please contact me and we can talk about it, ask me questions, whatever you need. Contact me directly at president@mnastro.org, and we can talk about it. We're going back there in January before the next meeting, and we're going to have a training session with them again, just to work out some of the bugs that we had when we were there on Tuesday this week. It was pretty good, but we know it can be better. We're not going to win any awards or anything, but it's going to be pretty good, especially if we knock out that last couple little things. So if you're interested, get a hold of me. I certainly would love to help. And then just a reminder that we still have that
quick
tool.
question.
Yes.
Will the room be heated and air conditioned? I know we had trouble with air conditioning and
No, Bernie, there's no roof either. Bring your umbrella. No, it should be completely air conditioned and heated, and I think it's going to be as comfortable as at home.
It's a brand new building.
It is a brand new building.
Yeah,
What else can I say?
with really, really nice audio visual. Multiple screens, multiple inputs, good sound system. It's going to be just so nice to work with.
Yep. So, Bernie, you won't be back until May anyway. We'll have all the bugs worked out by then.
This is true.
All right. All right. So just let everybody know that Slack is out there. If you are looking for an alternative to communicate with other members, that certainly is a great tool. I know that, I see members joining all the time, so that's great. It's not that this is going to be the main tool or a replacement for any other tool. It's just another tool, and it's another way for us to get information out. And sometimes I think the information sometimes flows a little quicker over there. I know the board, the board has their own separate channel, and we communicate on there all the time about just little things, and it's really great. I really appreciate it. You can even do video calls and things like that, and chat back and forth, individual to individual, and that all stays private between you. It's great. So join.
Yeah. One of the things is, well, anyway, I'll leave that for another time. Never mind. Go ahead.
All right. Thanks, Matt. Just a reminder that MAS is on YouTube. And I should think about making that a tiny URL. That way that's easier. I'll do that for Nick. But if you do a search for Minnesota Astronomical Society YouTube, it pops up every time. At least it does for me. And so somebody finds out it doesn't, I certainly hope that they would let me know that that doesn't work and I need to fix something, or the board needs to, or we need to find somebody to fix that. So let me know. Lunar Scope program. I know that Anton is
just real quick about the YouTube thing. I'd like to add this too, is that when you do look it up, if you do get it for the first time and you're not a subscriber, it'll give you the introduction to the MAS video, which is really good, really worth watching just to get a general overview too. Okay, sorry about
thanks,
that,
Matt.
interrupting.
So, Lunar Scope program. Anton is not on. Anton let me know that he was going to miss the meeting tonight. Fine. He did let me know that we have 2 new scopes coming online. Celestron 6 SE, and we were donated a 8 SE. Those are both go-to scopes, and those are going to be coming online. Matt alluded to it in the treasurer's report that we sent some money. Actually, one of those was the 6 SE. That was a replacement for one of the broken down, used up, which is awesome. I love it to hear that, the scope was used so much, it's just wore out. It's just not, the duct tape is coming off and it's not working anymore. We need to buy a new one. I think that's incredible. That's great news. That means that we've used it and we wore it out, and we'll send it away. So he let me know that those 2 are coming online. He thinks that he'll have those ready to go in January. And then he said, be sure. And so then he also said that there's few available. Go online to the Lunar Scope page and request any scope that's available there, because I was on there today looking for this stuff and I saw that there's a few available. So you never know when you're going to catch a really cool and a really warm morning where you can go look at a comet, which I'll get to in a little while. But the other piece that he wanted me to remind you of is that we have all these astronomy courses on DVD. And I went, wow, I think it's time for me to just make a slide just to show everybody what's there. And I was kind of surprised because I knew there was a lot there, but I didn't realize that there was this much there. And there's some even new ones. I see some 2021 there. Great heroes and discoveries of astronomy. That sounds kind of interesting, actually. And then it looks like there's one right up Matt's alley there, radio astronomy. I think that's really cool. So check them out and get a hold of Anton, and you can swing by his house and pick those up. It's all for the Lunar Scopes. So some events before the next meeting. New moon on Saturday. Total eclipse on Saturday. Not here. That would be Antarctica. Anybody know anybody in Antarctica? I don't. The moon close to Venus in a few days, but the real exciting part is, I guess I didn't put it on here, is the fact that there's a Comet Leonard is nearby, and that's a morning object. I don't know if Clayton's on. I was like, give Clayton a bad time about you got to get up really early to go out and see that one. I have my alarm set for the next few days for 4 a.m. just to get up and get out and see that. So pretty cool. Geminid's meteor shower. I'm kind of interested in December 14th. In between, the moon might interfere with that, I presume, but at least it sets. Sure, it's 4 days before the full moon, but I think you'll be able to see some good stuff. Winter solstice. And then I was going to check on that, but I ran out of time today. I would like to know where the moon is going to occult Mars. I presume it's not here because that would be I think that would be front page news for us, because I think that's kind of exciting. And then new moon January 2nd before we get back together. And then the next meeting, hybrid meeting, January 6th. 7 p.m., Fairview Community Center. Think about it. If not, hey, join us on Zoom. We'll be there. I'll be there. Star parties.
Oh, and Mark, do you think we might be able to do the old Chicago thing as tradition?
Can you wait till we get there?
Oh, you're talking about that?
No, it's not January 6th. It's December.
But the answer is yes.
Yes, yes.
I'm a yes.
Yeah, okay. All right, moving along. Star parties. There are no scheduled star parties. But, Trina, you want to say something about CGO? Because there has been late breaking news on that too.
It's okay, but I'm in for Old Chicago as well. CGO, hopefully at some point, maybe this winter or in the last few months or next spring, everybody will be able to go down and use the new concrete pads that are out there. Let us know how you like them, and we're still gonna work on some new improvements for next year and stuff too. However, one improvement, or well, maybe not improvement, but change, is that we're not going to have any official star parties other than the Messier Marathon, the 4M, and the Virgo Venture, because those are the ones that get touted. Everybody searches for those. It's just that way we're not confusing the public that they're going to be public star parties, and CGO is a member-only site. However, we're still going to welcome the public if they happen to stop by. We'll show them the sites, show them some fun telescopes, but otherwise we're going to take all the other star parties off and just leave it for us using the forums, our and ISPs and stuff like that to promote that you're going down there. Thank you.
And those other three that you talked about, the 4M, the Messier
Yep.
Marathon, and Virgo Venture,
Yes.
If you complete those, it's a possibility you could win a prize.
Possibility to what?
Question
Win
for
a
you.
prize. Okay.
Oh, prizes. Yes, prizes.
Hi, Ken.
Hi, had a quick question. How's the stroke cart coming along for the bad?
He's still working on it. The BAD has a little bit of a different base system than the ones up at LLCC. So I'm hoping that within now, between now and spring, he'll be able to have something for us to work with. Just due to the base plate that's on it, he's got to work around that. So
That's a Star Master, not a obsession. So it's designed a little differently and requires a little more creativity in making the cart.
correct. Yes. Yeah, but it's still in the works. So it's going to be part of our budget for next year. So nobody get too shocked by that.
Cool.
What's
All
up,
right,
Ken?
very good. Cool, thanks, Ken. COVID, nothing's really changed. We still require masks everywhere that we're getting together. For sure where it's public, and for sure where, there's more than one member in a building. And that's regardless of your immunization status. And then there's no restrictions to ISPs, but we would like you to post that you are going to be at a site. It's just in case, especially now with this new variant. Thank you, another variant. That we, if we need to, we can track somebody down, and just let somebody know that somebody was around you that may have been sick, or vice versa. So thank you all for doing that. I see it being done. I monitor forums not regularly, but periodically, and I see that tool is still being used, and I appreciate that, and that's what we need. BSIG, December 18th at 1 p.m. It's virtual by way of the Zoom. Dave Faulkner.
Yeah.
You want to talk about this, the great debate? I'm kind of interested about that.
So the Great Debate occurred in 1920, and it was advertised as a debate about the nature of what they called spiral nebula and the size of the universe. There were other things that came up in the debate, however, that also altered how we look at the universe and how humanity looks at itself in the universe. So I think people find it quite interesting, and I'm going to leave it at that. Come listen; it'll be fun.
All right, I love the tease. All right, moving along. Call every month. Every month, I'm going to call for Gemini articles. There are 694 members. So let's see, we take off the 100 or so new members for 2021. So there's still around 600 of us that probably have had an experience that we could write something about and give it to Father Brown. If all 600 of us would write one page about something and turn it into Father Brown, you wouldn't have to see this slide probably for a couple of years. That's all it would take. And it'd be, I think it would be kind of cool actually, but I know I'm afraid to write something down too. So I get that. And, but if you have something, turn it in. I don't think he's ever said, oh no, we're not doing that. Yes, I saw that, Dean. Dean, good idea. Yes, I agree. New members, if you experience something, you can do that. So you can do it too. I'm not just limiting to members who've been here 1 or more years, but new members too, please. Anybody. Thanks. So I want to talk a little bit about this comet. I was intrigued by it, and I blame Chris Setness on that because he went out on November 28th and he shot some pictures. And he made a nice composite of it, a nice pile of it, a nice stack of it, and I didn't think much of it. I knew it was there. I'd heard about it, and I knew it was visible and things like that. And I just wasn't motivated until I saw the picture. And then I started looking into it, and I started looking at my observing field, and I was on it. I crawled out of bed this morning at 4:15, and I was running by 4:30, and I was collecting data. So my data's not bad, but I can't show it because I lack some skills. But anyway, this comet discovered, less than a year ago at Mount Lemmon by Gregory J. Leonard. It's got an orbit of 80,000 years, and from what I learned today is that this is a one and done. It's going to pass the sun on January 3rd, and as it leaves the sun, it's never going to see our sun again. It's going to be, from what I understand, ejected from the solar system. It's going to be gone. I guess it comes from the Oort cloud, and they keep saying that it's going to be fourth magnitude. I don't know. I looked for it this morning with my binoculars. I guess I have to wait till it gets closer to a bright star, because from where I was looking, it's kind of light polluted, and I was having trouble. I couldn't find enough stars to string together to make a line to get from one place to the other to find it. So it was too far from Arcturus. Let me just say that. Passes closest to Earth on December 12th. We're not going to be able to see that here in Minnesota. It's going to be too low. It's going to be too close to sunset or sunrise. So that's going to be unfortunate. So I found this path graph, and I thought this is a good deal. And so you can see how that thing's it's speeding up, and then then it's obviously it's going to just slowly just depart us. But I was impressed by it. It's going to be like in Buddhas for I think starting tomorrow. Let me see. Yeah, starting tomorrow sometime after lunch, I think it's going to go into Buddhas. and it's going to be there until the 8th or so. And then after that, it's going to be like moving a constellation almost a day, because of its trajectory into our solar system. So there's that. I thought this one is simpler. It's more zoomed in. It's more for us. And you can see where we are right there on December 2nd. That little green X that you see there, that's what's got me all excited about tomorrow morning, because it's that's M3. That's the A number 3. And then I was looking a little further and looking at my field of view with my camera, and there's a whole little cluster of galaxies that are right there too. I didn't spend too much time going to find out what they are. I just gave that the cool. It's gonna be photogenic tomorrow morning. So I'm hoping and looking, planning on that weather being good. And
Is this view here, is this like looking almost due east?
Yes, it is. Yes. So everybody knows the Arcturus is the great star right in the middle. And when it passes through Boötes and it gets close to Arcturus, I believe that is 1 degree away from Arcturus. So for me, that's going to be photogenic also. And so we'll see how that goes. I'm, like I say, for the next, until I think Wednesday, I have my alarm set every day for 4 a.m. Wednesday might be a little early, because I don't think I'll be able to, it won't be high enough yet by then. But it's incredible as to how quickly it recedes from the eastern sky. I mean, this morning, I think the highest it was is like 38 or 39 degrees this morning from my location at 5 a.m. So that's the highest it's going to be now for forever. I mean, it's not going to get any better, and it doesn't matter if you get up earlier. It's the fact that it's not rising for us.
So what's the estimated magnitude right now?
I saw 7.
7.5.
Yeah, it's and I presume that's why I couldn't find it this morning with my binoculars.
I think they predicted like maybe a mag 4 at the best.
Right.
But I think that's when it's going to be, the opposite. It's going to be in the evening, I believe, and that the sun will interfere with it. Yeah.
And it's not going to get very high for us after sundown, because it won't be even close to being dark.
Yeah, after around December 12th, it's going to leave the northern hemisphere. We'll have trouble seeing it. The other thing that's come out in the last few days, there's a couple of jets that have popped out on the comet, and there's fears that it might be starting to disintegrate. So it might not actually get to the full estimated 4th magnitude at the peak, but it'd be interesting to keep an eye on it and see what happens.
Yeah. Thanks, Suresh. Good information. I knew you'd be on it. Otherwise, that's all I got. I'm pointing it out that it's there. I know it takes some motivation to get out of your nice warm bed in December and go outside at 4 o'clock in the morning, 5 o'clock in the morning. But I know there are some of you that get up because you're getting ready to go to work and stuff.
Well, at least it's warm.
At least it's warm till what did I see? Till Saturday tomorrow.
Yep.
Saturday, the highest 34 on Saturday, just to let everybody know. Jerry, better know a constellation. And I talked to you a couple days ago, and you thought maybe you'd carry on a little something about my Comet Leonard. So I'm going to stop sharing and let you share.
Hi, everybody. So I think you guys did a great job on the comet. So, and I only have about 8 minutes. So what I'm going to do is I'm going to scoot right to our better know constellation. And my apologies if I am doing a lot of hemming and hawing here. I'm in the process of having fun with a cold. My first cold in 2 years. It's so exciting. Yuck. Anyway, we are going to talk. Can you guys see this okay? Are we on?
You're on, Jerry.
Awesome.
I can hear you and see you.
Awesome. So, so the better known constellation today for the next 7 minutes is going to be Auriga, which is a pretty cool constellation. There's a lot of pretty awesome stuff. It is one of the 48 that was identified by Ptolemy in the 2nd century, and you can kind of see here by taking a look at this image here. It is typically, it's some way, shape, or form. It is the mythology, at least the Greek and Roman mythology, has much to do with Auriga either being a charioteer or having something to do with goats. Excuse me. And it's really interesting actually to read what other cultures have perceived this. Let me get rid of, first I have to get rid of this. How do I get rid of this? All right. Am I still sharing? Have I messed anything up?
No, I can still see it.
Okay, great. I have this bar up here that I'm trying to get rid of. There we go. Let's put it way down there. All right. So
Actually, your picture hasn't changed.
no, but there was the zoom bar that was in the way.
Oh yeah, okay.
All right, so I'm going to get rid of the mythical, and we're going to take a look and see. So this is what Auriga looks like to our eyes. This is the pretty standard, and there doesn't take a whole lot of research to find out what other cultures. But so I want to spend a little bit of time just taking a look at Auriga as we observe it, since it's going to be up. It's up in the sky now on the eastern side of the sphere, and it is going to get higher and higher as December goes along. Obviously, Capella is the brightest star. This little animal right here is known as Almaz, which is Epsilon Auriga, which is perhaps the weirdest star in the sky. And I encourage you just to look at it sometime. Just say, hey, dude, you're really weird. It is eclipsed by something larger than itself. At least that's what the pros think. It's got a 27-year periodicity to its variability, which is pretty crazy. And these are called the two kids. And I was out just the other night taking a look at these, and the color difference between these two stars is really quite delightful. So I would encourage you to take a look at those, and at those two in particular. There's a couple of really cool double stars. There's Theta Aurigae over here, which is a fairly close double. It's a telescopic double, difficult to see, but it requires about 200 mag in order to see it. But it's a close double, and the primary is about a 2.6, and the secondary is about a 7. So when you get it, it's really cool thing to notice. And there's also another very cool triple star over here, 14 Aurigae, which is another telescopic double, but it's a triple, and it's really quite pretty. I'm going to be curious to see if you guys like seeing the dark as opposed to the inverse. Let me know what you think works best. So as you've noticed, that Auriga here is right in the middle of the Milky Way, so it has quite a number of open clusters, and I'm going to turn up the open clusters a little bit here, just by doing this, so we can see where they all are. So there are quite a number of open clusters in here, and many of these are really great to look at. And I'm going to put a list of the 9 small open clusters that I found as I was looking through this constellation a couple of nights ago, and I'll put them up on the observing forum, and really encourage you guys to take a look at them. They're all telescopic, but there are 3, and I'm sure all of you guys know this already. There are 3 that are really great in binoculars. I'm going to turn this down a little bit, so we see just the 3 main ones. And these are Messier objects: Messier 37, Messier 36, and Messier 38. This is the least of the Messier objects. Let's just kind of look at it a little bit. these are wonderful star clusters. And so they're very bold, very brilliant. You can see there's a lot of color in it. Some of the color comes out depending upon the skies that you happen to have. The next one is right here, and it is also known as the pinwheel cluster. And you can see how different it is, how different it looks from M37. It's just different. And that's one of the cool things about open clusters in and of themselves is they are, every single one of them is different. Some of them are like this one here, and M37, 36 and 38, which we'll get to in a second. And there's another one, there's one in this area, I think it's NGC 2126, but it's only 3 stars. And it's kind of cool to find and to look at it and say, my word, that's a cluster. Here's M38, which is also known as the starfish cluster. And you can see, again, these are vivid, and these images don't really give you a lot to work with. They're so much better in the eyepiece. There are a number, a Mission Nebula. There over here is the Flame Nebulae. These two are emission nebulae. Here's a wonderful cluster. This is NGC 1893, and that's embedded in 401, 410, I should say, IC 410. And even in my suburban skies here in Stillwater, with a UHC, I was able to see some of this. I was able to see some of this, and I was able to see some of this. So don't hesitate getting out your filters and taking a look at that. But some of the best parts of this constellation for me are the things that you can see is this in particular. And I call this the constellation of the CSF. And I'm curious to know, let me get rid of that, put that over here. I'm curious to know if, as I zoom in here, if you happen to see anything rather interesting and rather obvious. And I'm hoping what you see is right here, the CSF, the cosmic smiley face. And this is unbelievably obvious. Take whatever pair of binoculars, get outside, take a look at Auriga, plant your eyes right in the middle of the constellation, and you will, and it will just pop out at you. And what's especially cool is that M38 is a blotch on its cheek right over here, and that's just really fun how these interesting coincidences occur. And then right next to it is another asterism. This is called the flying minnow. Not quite as obvious, at least to my eyes, as the cosmic smiley face, but this asterism is really fun as well. So there are so many of the open clusters I didn't get a chance to get to, and that's okay. I'll put them on the forum, and I really would encourage you to spend some time taking a look at this next month as it climbs higher and higher. And with that, I encourage you guys to get out there and observe.
Thank you, Jerry. Okay, I got to share because I got a couple more slides left. Stand by. All right, there we go. Thank you, Jerry. Let's see. Jerry, are there any Astronomical League awards?
Haha, I was wondering if you were going to ask that question. So I have 2. I don't think Dave Tosteson is on. If he is, feel free to chime in for a second or two. Dave Tosteson wound up getting 2 of them this month. He finished his Southern Sky, or we should say he finally got all his logs together and handed in his Southern Sky Constellation Hunter. And that was pretty cool to see. The second one that Dave did, and this is a statement to the decades that this guy has been observing, and we all know this. We've all read his articles in multiple magazines. This last month, he was awarded the gold certificate by the Herschel Society through the Astronomical League for having observed all 2,398 objects on the Herschel list. Oh my word. So congratulations to Dave. And I really encourage you guys to continue working on this stuff. I'm really looking forward to getting back to our meetings so I can present these certificates in front of the whole club. I think that'll be cool.
Thank you, Jerry. And what do you have to say for yourself?
Get out there and observe.
All right, very good.
Nice shot, Conrad.
So next month, January 6th, live and in person. I guess that's not for sure whether or not Professor Evan Skillman will be in the house, but we're going to certainly offer that to him and offer to him the option to do the Zoom. That's up to him, and but he will be the speaker. I haven't heard what the topic is going to be, but we'll get that posted on the website as soon as we know. So that takes us to our featured speaker tonight, Professor Patrick Kelly from the Minnesota Institute of Astrophysics. He's going to talk to us about galaxy clusters and the magnifying glasses, the giant magnifying glasses. I'm excited about that. I'll stop sharing. I know Professor Kelly is on the call, and I can see his face, but I can't hear him.
Hi.
And I'm turning the whole show over to you. So
Wow.
all you have to do is share, and we will sit back, relax, and enjoy. And I presume there'll be time at the end. You'll save us a little bit because we always have questions, and we always like to chat it up with you. So we're looking forward to that. And welcome to the MAS, our monthly meeting. It's great to have you. I'm excited. I like the magnifying glasses. So it's all yours, Patrick. Thank you.
Great. Well, yeah, thank you, Mark, and thanks for the invitation to talk with the group here. I've been, to just a little background, I've been in Minnesota for 4.5 years now, and at the U, and so I'm an assistant professor, and I know your next speaker very well, Evan Skillman. Anyway, so I'm sure I'll have a great talk for you guys next month. So the main focus of what I'm hoping to talk about is galaxy clusters and gravitational lenses, but I thought I would share something before I start my talk about another project I'm working on, and I thought it might have some appeal to you folks who have work with celestron telescopes and that kind of thing. So I've just got funding for, actually $1 million from the National Science Foundation to build a set of telescopes in Magdalena Ridge Observatory, New Mexico, and another in Crete to follow up within 2 seconds alerts from LIGO, so gravitational wave mergers detected by the site in Hanford and a couple other sites around the world. So we built this prototype in St. Paul here. Can you see it? My screen? I just want to make sure.
Yes, we can. It's
okay,
terrific.
Great.
I love it. I'm envious. I want
so, yeah. So let me show you. I mean, you're probably all familiar with these direct drive mounts, but in any case, we can use it to slew anywhere within about 2 seconds and start taking images. So we're working on this. The interesting thing is that the mount does not seem to be very stable in about 20 km/h wind. So we're working on trying to come up with maybe a friction drive or something that can be attached with a clutch. But anyway, I thought that kind of might be of interest to you folks. And I'm actually working on another project, possibly involving drones and building large telescopes, and hoping to learn more about how to grind mirrors. If anybody is interested in talking about that with me, I would actually be, me and a couple of students would love to talk with you. So, all right, enough of that. I will, let me try to find my talk here.
What size telescopes were on that mount?
Well, those are 8-inch.
8-inch,
Raza, yeah, but we're actually thinking of switching to 11-inch telescopes instead. So,
very good.
Yeah. All right. Let's see here. Okay, so I'm going to talk today about galaxy clusters, which are the largest virialized masses in the universe, and they're also very powerful gravitational lenses due to their mass. And so let me start out with a little bit of background. And so Isaac Newton thought about a question, this question, which was how does matter affect the travel of light? And it turns out if you shoot light near a body, like the sun or the Earth or a galaxy cluster, it is bent, and indeed Newton suspected this was the case, and suspected that the closer the light traveled to a massive object, the more it might be deflected. But that was sort of where he left things. And it wasn't until Cavendish in the late 18th century derived the expected deflection angle due to a mass in the Newtonian framework. So that there's his formula. Einstein, while he was working on his theory of general relativity, revisited this question. At first got the same formula, but he had only included gravitational time dilation. He then included the effects of curvature, which gave him a prediction that the deflection should be twice as large as that you would expect in the Newtonian picture. So this provided a great opening to test the new theory of general relativity, and it's a prediction. Testing a prediction is maybe the best test of a scientific theory, and I'm sure you're all familiar with this, but he detected or measured the deflection of stars near the limb of the sun during a solar eclipse. There's some controversy about exactly how accurate his measurements were, but I think the latest studies of this show that his measurements were in fact reliable and accurate. And so this was the first evidence for general relativity. This is a great beginning for the field of gravitational lensing. So, what is gravitational lensing? Well, it's can be thought of as a transformation between objects in the source plane and the image plane, which is what we see. And so, to some extent, it looks like a gravitational, an optical illusion. But if you have light, traveling from a distant source towards us, it will be bent by the source, as you can see here, and will appear as if it were in a different position. And it will also magnify the light. So after this seminal discovery measurement by Sir Arthur Eddington, however, gravitational lensing sort of fell and became a bit of a backwater. I think there was an amateur astronomer, much like some of you, who was wondering about what perhaps a star could gravitationally lens another star, which is now known as microlensing today. And Einstein considered this and thought it was an interesting idea, and actually they wrote a paper together. But he was pessimistic that we would really ever see this because he correctly surmised that it was unlikely that one star would become aligned with another, and in fact they do. But you have to look at million or thousands or millions of stars at once, which people couldn't really do back then. So observers didn't give up. This guy Fritz Zwicky here was a famous astronomer at Caltech, and he proposed that galaxies and galaxy clusters, owing to their large masses, could actually be powerful lenses. And so this was a very prescient idea, but the telescopes available at the time, or at least, but in any case, they weren't able to find gravitationally lensed objects. So just a little bit more about gravitational lensing here. So if you have here's the Earth in the bottom left, upper right is a galaxy, and there's an intervening galaxy here in the middle, which is spherically symmetric and perfectly aligned. And if that's your configuration, then you end up with a perfect symmetric Einstein ring. So we see these in nature, in fact. And here's an Einstein ring observed by the Sloan Digital Sky Survey. All right, so then break the symmetry. You may have a lens that's not symmetrical or have some misalignment, and the ring breaks up into arcs. So here's such a system right here. And in fact, this is also what you see if you look at a galaxy cluster. And this is the Hubble Space Telescope that has taken this image here, and you can see the large number of arcs. So here's another animation. If you have no lens in the way, and then if you put say a cluster, you end up with something like this. And of course, clusters, like galaxies, are predominantly composed of dark matter. So it's a great trying to model these sources we see in their shapes and where they appear, gives us a way to probe the distribution of dark matter in the galaxy cluster, which of course we can't see directly. Turns out, I don't know if any of you are drinking a glass of wine right now, but if you are, then you have a mini gravitational lens simulator in your hand, and you can actually use the stem to create an Einstein ring or arcs. And so it turns out that the optics of the bottom of a wine glass are very similar to a gravitational lens. There's also an app which you can lens yourself if you want. So that's a little bit of background. And as I mentioned, there wasn't really any observational work outside of our solar system following Sir Arthur Eddington's observations for the next almost 60 years. And this was the first gravitationally lensed object that was found strongly lensed, and it's a twin quasar, very bright, I think 17th magnitude, I believe. Maybe, I don't know if that's bright for people in their backyard, but anyway, you can see there's an early type galaxy lens there. The first giant arcs were found in the 80s. There's Su'Kale and Abell 370. This was the first arc found. It was from the ground. You can see the image on the left there. It was taken from the ground. And on the right, you can see the Hubble Space Telescope image. So Hubble is fantastic for this project of looking for gravitationally lensed galaxies because their surface brightnesses are low, and to see them, it really helps to be in space where there's less background. So go back a few years in the middle of the doldrums for gravitational lensing, theorists were still thinking. And a Norwegian astronomer, Sir Refsdal, realized that if a supernova exploded in a strongly lensed multiple image galaxy, and we saw it occur multiple times, we could try to measure the time delay of its appearance, relative time delays of its appearances, and from the relative time delay and a model for the galaxy or galaxy cluster, we could, in fact, measure the expansion rate of the universe. And so the idea is fairly simple. It's just that if you have, say, two images of a supernova, you can measure their distance on the sky. And after you take out the effects of the gravitational lens, you can figure out how large these triangles are by using c delta t. So the time delay times the speed of light gives you the difference in the sides of the triangle. And if you have all the angles and this difference in the size of the triangle, you can then figure out how big the triangle is and establish an absolute distance scale for the universe. And then combined with the measurement of the redshift of the objects, constrain the expansion rate of the universe. So Sir Refsdal made this prediction, or at least he considered a supernova that was strongly lensed. It was another 50 years until we actually found one. And in the meantime, people started to actually apply his ideas to multiple image quasars. So there's a whole industry. But I was lucky enough to find the first multiple image supernova in 2014. And amazingly enough, it appeared as 4 images in this galaxy cluster field, and then we actually predict that it would reappear in another image of its host galaxy formed by the galaxy cluster a year later. So here you can see the red circles. Those are 3 images of the same galaxy at redshift 1.5. So that's a look back time of 9.3 billion years. And so the supernova, of course, when it explodes, the light travels towards us, and so we should see it explode in each one of these images of the host galaxy. So we missed the one in 1995. No one was looking. You would really need the Hubble Space Telescope to see it. And then I was lucky enough to find the 4 yellow images there on the bottom right. And what we were very lucky, in fact, because not only is this supernova multiply imaged by the galaxy cluster, also there's an early type, elliptical galaxy there that multiply images the part of the galaxy where the supernova exploded. So it's doubly multiply imaged essentially. And so we found this Einstein cross in 2014. And then we predicted it would reappear in this more central image closer to the center of the cluster. So if I were teaching a class, I might ask why. Well, why is it that it appears last in the image that is closest to the center of the cluster, where the path is least through the cluster field, right? The galaxy is behind this cluster, that's why it's lensed. And so the light that goes into the 95 image, has a longer path to get to us. So the answer is that this is general relativity at work. The center of the light that goes through the center of the cluster has to contend with gravitational time dilation and the curvature of space. And so that's why it actually takes longest to come on the most direct path towards us through the cluster. So this is a distance of about 8 arc seconds. And so here's a diagram showing the path that light is taken towards us. All right, so modelers were able to put together these really exquisite models of the galaxy cluster field to make predictions about when the supernova would reappear. And so you can see on the left the HST data, on the right model. And then here's the Zitron cluster mass map. So as one of the groups, you can see that the predictions have different maps of the total mass distribution in the cluster. And most of this, again, is dark matter. So this is a way to test the predictions of the cluster models. And it turns out also the expansion rate of the universe. So here is a plot showing the predictions of all of the big teams around the world who model galaxy clusters about when the supernova would reappear. What's the time delay between its appearance in 2014 and then its subsequent reappearance? And so we didn't know when it would reappear. And so all these teams got very excited, made predictions about when this would occur. And you can see this arrow showing December 1st of 2015. And so most of the models predicted that the supernova would reappear before then. And so I organized an imaging campaign, and we started in the fall, didn't see very much. And then lo and behold, in December 2015, there was a supernova. And this was the first time anyone was able to predict the appearance of a supernova in a particular place on the sky, which was very exciting. Here's a deeper image, a co-edition of images taken during the spring. And from the first observations, we were able to kind of constrain, within 45 days when the supernova, what the time delay was. But that was just with a little bit of data. We now have far more data, and we have a paper under review right now reporting a very precise time delay. Actually, it's accepted. So I'm sure all of you are familiar with also the current controversy about the value of the Hubble constant, or maybe you're not. But in any case, if you're in an expanding universe like ours, the velocity at which objects move is proportional more or less to their distance. And this constant proportionality is called Hubble's constant, or the Hubble constant. And there are sort of here's Hubble's original measurement. And so what you do, one way to measure this is just to measure the distance to nearby galaxies and measure their redshifts, and then use that. And so that's called the distance ladder approach, one that is used to calibrate the distances of Cepheids using parallax measurements, and then Cepheids used to calibrate type 1a supernovae, and then type 1a supernovae out into the Hubble flow, where the velocities of objects are dominated by the cosmic expansion, universal expansion, as opposed to the peculiar motions arising from gravitational interactions with neighbors, for example. so that this method gives us maybe about a value of about 72 kilometers per second per megaparsec, and then a very different measurement of instead the cosmic microwave background, coupled with the assumption of what's called the lambda CDM cosmology, which is the current, the current paradigm or best model of a cosmological model, implies a lower value of the Hubble constant of about 67. And so there's a big tension here. People are trying to understand, maybe one is an erroneous measurement, or there's systematic errors we don't understand, or if this is a real difference that would imply the existence of some kind of physics we don't know about yet, which would be interesting. So here's a plot showing different measurements of the Hubble constant over the last 20 years. And so you can see that there's disagreement between the CMB, the cosmic microwave background value, and the Cepheid value. And then there are a number of other measurements, and some of them fall a little in between, others, are on one side or the other. So we really need more measurements with different, errors, systematic errors, to try to resolve this tension or understand it. So Refstal, which is what we name the supernova, provides the opportunity to do that, or to provide an entirely new measurement of the value of the Hubble constant. So here you can see its light curve shifted from all of the images together. So Refstal is the first multiple image supernova with resolved images, and we're able to predict the appearance of a supernova on the sky. We've also measured the expansion rate of the universe, and the paper is currently under review at a journal. And so hopefully the value will come out soon, which will be exciting. So that's the first part of my talk. And now I'm going to switch gears and talk about a second phenomenon that we discovered actually during observations of supernova Refstal. And Refstal motivated a lot of Hubble observations. So I think in total maybe 100 orbits, and so orbits around 90 minutes for Hubble, and so a lot of time. And so this was kind of an unprecedented campaign imaging a galaxy cluster, and in that process we discovered something very unexpected. So here is the image of, an image of two images of the host galaxy of Refstal. And there's a line called the critical curve going between them. So if you're familiar with gravitational lensing, you know that the critical curve is a special curve, as the name suggests, and that's where the magnification would be infinite for an infinitely small object. So the magnification due to the galaxy cluster rises towards this critical curve. And so here we're going to observe Refstal, and here's an image of the cluster in 2011. Here's an image showing the reappearance, and see if you can see there's something else in this image here. This is in late May 2016. You may have seen it. It's this highly magnified star, and so a new source in a very special place right next to the critical curve. And so what we're seeing is an individual star more than halfway across the universe being magnified enough by the galaxy cluster such that we can see it. The next most distant stars we can study directly are actually 200 times closer than this. So this is kind of a window into the universe when it was 9 billion years younger, and as something that was not anticipated, except for a couple of papers from a long time ago, but people more or less forgot about them. So this star, which we called Icarus, continued to brighten in May 2016, and there was a peak. And so it turns out, you might ask, why is it changing in brightness? And so the answer is what's called microlensing, and we think objects in the cluster are moving around and changing the magnification of the background star. And our models of the microlensing can account for what we observe. So what kind of star is this? Well, it's actually just a blue supergiant, and And so we think it's actually, supernova Refstal was a weird kind of supernova. It was much like 87A, which was the explosion of a blue supergiant. And so here's another blue supergiant. And Rigel is an example that you probably know about. So this is very exciting. And here, why do we think it's a blue supergiant? Well, here are measurements of its brightness as a function of wavelength, and you can see this prominent Balmer discontinuity, which you don't see in stellar eruptions, because you need enough. Basically, the density is too low for that to exist in the spectra of stellar outbursts or supernovae. It also provides a great diagnostic of the star's temperature, and so it's around 1100 Kelvin. So I mentioned microlensing, we think, is the culprit here, explaining the flux variation of this highly magnified star. And so what's happening? Well, here we are on Earth. We see, in general, we see multiple images of background objects. And if an object moves in just the right place along the line of sight, then it can additionally magnify it, causing it to brighten. And so that's what we think happened. A little later, so at first we saw Icarus as the object, or the object that brightened, and we didn't see anything on the other side of the critical curve. So you may have noticed that there are two images of the galaxy, host galaxy of Refstal, and so these on each side of the critical curve. And so this is what's called a fold caustic, where you get actually mirror images of the galaxy or whatever it is on opposite sides of the critical curve. So that's what you would also expect for a star. Maybe we didn't see it. We only saw one image. A little later, we actually saw a second image. And so we think that image was more or less demagnified for a while due to perhaps some other object on the other side of the critical curve that had the effect of demagnifying the image. And here's just so it could have been, a black hole or a neutron star, but more likely it was some kind of star. Here's a plot showing the magnification of objects due to a galaxy, due to objects in the galaxy cluster. So each of these, darker regions corresponds to a star, and the brighter regions correspond to, highly magnified regions close to each star. So here's a video showing what happens as, oops, yeah. Oh, there we go. Okay, so here's a video showing what happens so what's happening is that the galaxy cluster, the Earth, and the background lens galaxy are all moving relative to each other. And so this causes the background star to move across this magnification pattern that's created by the stars in the cluster. And that's what causes its magnification to bounce up and down. So right now we don't know what dark matter is. That's one of the big mysteries in astronomy. And one hypothesis was that at least some of it could consist of black holes that were formed in the very early universe, which are called or termed primordial black holes. And so if you throw in primordial black holes as accounting for some fraction of dark matter, it really changes the magnification pattern you might expect. So you can see here, if you have these primordial black holes, that you get lots of little images at once instead of a smaller number of images. All right, postdoc and another professor at Minnesota and I discovered yet another star, or really a second star here, which we called Warhol, for the 15 minutes of fame idea, as it was microlensed and became brighter. So this is also a blue supergiant. So here is Andy himself, and the Minnesota Daily tried to do a Warhol inspired work of art here for the paper. It's kind of fun. And there we see two images of this highly magnified blue supergiant. So you can see that here this is optical Hubble imaging. And so the number of microlensing events we see tells us what's floating around in galaxy clusters. Is it primordial? And we can then probe, is it primordial black holes? How many stellar mass black holes? And so it's a new window into the population also of luminous stars when the universe is much younger. And we can only see these because of the galaxy clusters. So James Webb and galaxy clusters may even lenses may even allow us to see the first generation of stars due to their extreme magnifying powers. It's very exciting. Right now, I'm leading a large program with the Hubble Space Telescope to try to find dozens of these stars. And we've actually found a number. And what we're doing is we're using 192 Hubble orbits, which is a large program, and essentially using extremely wide filters, so almost no filter at all on Hubble's WIFC-3 camera. And so the idea is stare at these targets for 16 orbits, which is something like a day, and without a filter, and just let as many photons in as possible, and try to get very deep, because that is the best strategy for finding these microlensing events, since they vary quite quickly in some cases. So that is my talk, and so yeah, I want to thank you for inviting me. I'm also happy too, if there's time left, to talk more about the turbo, well, it's called the turbo project with the I showed you with the Celestron telescopes. As well.
Yes, there's time. There's plenty of time. We got like 25 minutes. So
really? Okay.
Yeah, so I mean, I know that there's some some mirror grinders on this call, so you probably be able to make connections with them. And then there's also anybody that has any questions about anything you talked about. You certainly can open up your mic and ask away. I didn't see anything come through in the chat that was a question in particular to your talk, but yeah, the turbo sounds fun too. So.
Okay, sure. Yeah, so I'll go for that then for a few minutes here. All right, so I showed you the Celestrons, right? And so this project there is called the Total Coverage Ultrafast Response to Binary Mergers Observatory. And so the binary mergers here refer to the mergers of neutron stars and pairs of neutron stars, as well as neutron stars and black holes. And so it's quite a group. It's a group of us, both at the University of Minnesota and the University of Crete, as well as New Mexico Tech and the University of Texas. And so the motivation there was that. So since 2015, LIGO has been able to find about 90 mergers of neutron stars and black holes, and the most exciting event was in 2017 when, as you may know, the two neutron stars merged, and LIGO detected this, and we were able to find the optical counterpart of the merger, which was a kilonova explosion. So if you have two neutron stars that get close enough and they become closer and closer to each other as they radiate gravitational waves, eventually they will merge with each other. And in the process, you have a very neutron-rich environment that synthesizes so-called R-process elements. So these kinds of things that are hard to produce in other environments, and they will radioactively decay and power a what's called a kilonova. We think that a significant amount of the gold and uranium on Earth probably come from these. So after this alert, people started looking for this optical counterpart, because it would be very exciting if we could figure out what happens when two neutron stars merge. And in this case, we were really lucky. The challenge, of course, is that LIGO is only able to localize mergers within about I don't know, it varies a lot, but hundreds of square degrees on the sky. In this case, it was a little better than that. But it took 11 hours to find this kilonova that emerged from the merger of the neutron stars. And the 11 hours meant that we missed a critical window where observations could have constrained the physics of the merger much more precisely, and whether it was powered to radioactive decay or shock heating of the ejecta. And so this is really the only of the 50 or now even maybe 90 mergers that LIGO has detected where we found an optical counterpart. There may be more exotic things that could happen, like you could have two charged black holes when they merge. You expect a burst of energy. That's a pretty exotic scenario. There could be other things like black holes with accretion disks that merge. When they merge, the accretion disks will light up. And so some of these processes could be very quick, on the order of seconds, and then they would fade quickly. And that's related in part to the size of neutron stars and black holes. They're so small that you can have really rapid things that happen there, and they can produce a lot of luminosity very quickly. So if you're waiting 11 hours, we may be in fact missing many of these events. And furthermore, if you take 11 hours to get there, there are going to be old supernovae that are brightening a little bit, and other kinds of transients, novae, right? And so you won't really know some of these. You'll have a whole group of transients in these large regions on the sky, and you won't know which ones to study. So Turbo, this project, we get there in 2 seconds, then we just sit there, and if we see things start to brighten right after the merger, then we know that they're already very good candidates. So it's a way of identifying more efficiently which transients on the sky may be the counterparts of gravitational wave mergers. So that's the idea. And so the thought is that current surveys may miss these. And so Turbo, our original goal was to get around 240 square degrees. And actually we had talked with a camera manufacturer, and they sort of have said that they actually won't be able to build the cameras that they had thought they would be able to. So we have to sort of shift gears and try and are talking to different manufacturers to identify a second solution. But we think we should be able to cover at least 150 square degrees on the sky. And here's an image we took sort of 2 seconds after commanding the telescope to slew over. One of the exciting things is also that LIGO should be able to actually detect these mergers as for nearby events as they're happening. So we'll get advanced warning that the actual merger will happen as the neutron stars start to in-spiral towards each other. And so that's very exciting that we could perhaps get to the explosion site before the merger actually happens. So it turns out Minnesota is a great place to weather test your equipment. So we've this is on the St. Paul campus, and we've had various issues we had to address, but that'll be good since they will soon be on the top of 10,000 foot or 6,000, 10,000 foot mountains. So we have a budget to build basically 4 of these mounts at each site, and the hardware here is, so this is an L350 mount by Planewave Instruments. So it's a direct drive mount, and then the 4 Celestron. I think they're we got the 11-inch ones. I think are F2 or F2.2. So very fast, and of course on an equatorial mount there. So this is the Roe Ackerman Schmidt astrograph. Some of you may have these. So here's one site where the telescopes will go. Skinnikos Observatory, which is the tallest mountain in Crete, and it turns out apparently a really great site. I think the median seeing is 0.7 arc seconds, and it's very dark as well. It's in the middle of the Mediterranean, and apparently not too much light pollution from the cities on the island. So here's the other site, Magdalena Ridge Observatory near Socorro, which is also the site of the Very Large Array. And so this is run by New Mexico Tech. Here's a 2.4 meter fast slewing telescope that I think is used in part to track missiles from white sands, but potentially we could use to respond to detections by turbo. So if we find something within 2 seconds or 10 seconds, then we can get a spectrum of it really quickly. Unfortunately, it's very windy at both this site and this site. As I mentioned earlier, in our wind tests in St. Paul, the plane wave kind of gets buffeted, and so we're talking with them about tuning the electric motors a bit, but we're also talking to someone who's building a friction drive with a electromagnetic clutch, and so the idea will be once we get to the target, we could engage the clutch, and then a friction drive is much stiffer, so it should hopefully withstand effects of the wind.
A question for you. I know you're using this primarily to identify objects that are the result of a LIGO detection, but could these also be used for like fast radio bursts or gamma ray bursts?
Yeah, no, that's right. Yeah, so we were hoping to respond to gamma ray burst detections, as well as neutrino detections, perhaps by ice cube. And during the time, we're not responding to triggers. The idea is actually to monitor nearby galaxies to find supernovae within a minute of explosion. So very high cadence search of nearby galaxies, and so that these will be the earliest detections ever of supernova explosions. The early light curves of supernovae, I'll talk about this now. So there have been so Kepler is a satellite that was designed to monitor monitor stars to look for transits and identify planets, but it also takes very high cadence data as part of that mission, and so astronomers have used that to study the very early light curves of some supernovae. Fortunately, it can't be used, or it wasn't able to be used to discover supernovae very early. There was so much data that it couldn't be sent down to the ground immediately, and so there was like a few week lag, and so that meant that if you recorded the places where the supernovae occurred, then you lucked out, but the satellite couldn't tell you it had just found a supernova. So we couldn't get other kinds of observations like multi-wavelength photometry or spectroscopy. And so nonetheless, these very early light curves are very interesting because the supernova luminosity is not yet powered by radioactivity, as it is after a few days, but instead it's just driven by the sort of the heat that remains from the shock material. And that's really more for core collapse supernovae. For type 1a supernovae, the radioactivity escapes earlier, but or radioactively produced energy escapes earlier. In any case, if there were, say, a companion next to the progenitor, then the ejecta from the supernova would slam into that and heat it up, and we should actually see that as a bump in the very early light curve. And we didn't see that for these few observations here, which suggests that maybe most type 1a supernovae don't have a big star next to them. There's some viewing angle effects there, so you really need a bigger sample than this, though. Another interesting thing that happens when supernovae explode, large, massive stars, that is that there's a shock that propagates to the surface, and for a very brief time, this shock emission will be very bright, and so we should be able to actually detect that with turbo, which would be very exciting. So here's a possible detection with the Kepler satellite. So TESS is kind of the successor to Kepler, and it has a much bigger field of view, not quite as big a telescope, and so that it has found some supernovae very early as well. So turbo probes a time scale that other surveys currently do not, and also it has and also is also much more sensitive than many of them. So the real challenge is we're going to be collecting a huge amount of data, and we need to process this within 10 to 30 seconds. And so we've started to put a lot of work into developing a pipeline using in part a software pipeline using in part graphical processing units, that people use for mining Bitcoins and playing video games and that kind of thing. But they're very good at processing things in parallel. So they have many small processing units in the larger chip. So turns out to be very helpful for astronomers as well. Part of the goal here will be public engagement through the Zooniverse project. So we're going to engage people in trying to confirm candidate supernova or counterpart detections. That's very exciting. And then if we detect a transient, we can tell all the telescopes to, for example, point in that particular region, get a very high signal to noise light curve, for example. So we're going to try to respond in real time to what's happening. And there's a little bit of a data storage challenge as well here. So we have a grant from the National Science Foundation called Major Research Instrumentation Grant, and our objective is to cover the entire gravitational wave localization area for about a significant fraction of the triggers from LIGO, and then also discover supernovae in nearby galaxies within seconds or minutes of explosion. And so we have a challenge with the mounts here, which we're trying to overcome. And then also trying to arrive at a final selection of our CMOS cameras. So that's where things are right now. But it's been driven in large part by undergraduates who have been working on this for their senior thesis projects. And so it's been a lot of fun so far.
Those things are very interesting. Those are very interesting. So I don't want to take, if you're finished there, there's 3 questions that came up on the chat, and
okay.
The first one was, have Hubble's problems and troubles interfered with your observing?
Oh yeah, not really. I mean, I think there were some observations that were a little bit delayed, but yeah, I mean, it wasn't down for that long, so I don't think it was a big. Well, yeah, no, I mean, well, to some extent it has, because I mean, as the people who schedule Hubble will say, it's an aging telescope, which it is, and so you can't. It's more finicky, and so you have to. They're much more conservative with how it can be scheduled, and we're really demanding observations for this flashlights program I was talking about, since we want to stare at the same region of the sky for about a day. It becomes hard for the schedulers to accommodate that, but it still worked out. So there are a lot of very dedicated people at Space Telescope Science Institute who are
excellent.
Excellent.
And then Shresh asked a question is how is James Webb expected to impact your studies of galaxy clusters and lensing and gravitational waves?
Well, that's a great question. Yeah, so I guess what James Webb is now supposed to launch at the end of the month, close to the end of the month, I think. So yeah, so I'm part of a couple different efforts to image galaxy clusters with that. Will be very exciting. We can so Hubble has more blue sensitivity. James Webb is far better at the infrared, and so it will be great at finding red supergiant stars that are lensed, whereas we found blue supergiants so far with Hubble. So in that sense, they're complementary. And then let's see. Okay, what else?
And then Ron Schmidt, you have a question you want to ask?
Yeah, back in 1985, astronomers found an Einstein cross in Pegasus. I understand the ring and the curve, but why a cross? Is that an interference pattern, or why 4 distinct images of that quasar?
No, well, that's just because I mean, you get a ring or an arc when you have a lensed galaxy, which is extended, right? But if you have a quasar, the light is coming from a very, very tiny point, right? A very small space. So it's basically quasi-stellar object, right? So it's a point source, and so that's where the cross comes from. It's like Restall, the explosion is a point source that becomes brighter. So that's why you don't get an arc.
Okay, you don't get an arc, but why do you get 4 images of it?
Why? Right. That's a good question. Yeah. So you actually always, there's a theorem that says you always get an odd number of images. And there's actually a fifth image in the center, which is not magnified, but actually demagnified. So there are actually five images. We can't see them all. So why, yeah, well, you don't always get five, in fact, right? It depends on the alignment of the source with the foreground galaxy lens. And so if they're, very well aligned, you'll get 4. And if they're off center, you could get, a smaller number. But there's not always the same number of images. It really depends on the configuration. And so if you're familiar with, Fermat's principle, right, that you have images form at the extreme of the time delay surface. The same thing applies for gravitational lensing. And so you can, make maps of this, and that's a way to find the images. But it depends on the details of the system.
Which principle was that you mentioned?
Fermat's principle. So, I mean, if in regular optics, you have light, passes through glass, and an index of refraction, it's not traveling as quickly. And so images will form at the extrema of the time delay surface. And so the same thing for gravitational lenses, except that instead of glass, you have the gravitational potential of the lens itself, which basically acts like a glass lens.
Fantastic.
Yeah.
Thank you.
Yeah, very good. And then one more question: is there any way crowdsource could contribute to turbo programs such as operating personal computer imaging processing time or things like that? And I was going, well, what about telescopes? I mean, every one of us has got a telescope. There's numerous of us guys that have telescopes that have cameras on the back. There are those too.
Yeah. Well, that was one idea that came up when I was actually talking with someone who in the department. Maybe we could get people to use their own telescopes to contribute to the sky coverage. So yeah, I mean, so one avenue here is that I think, well, there's a lot of data that needs to be processed super quickly. So I think one of the issues actually, we can't even transfer all the data off the mountain. So we have to actually process it on the mountain and only send the detections back to Minnesota, and then sort of slowly over the whole day send all the data back. So I think it would be hard to farm the data out to everybody. But as someone put in the chat here, there's something called Zooniverse, where we're hoping to put the detections on this website, and people can look at it and say, oh, does this look like a real transient, or is it instead an artifact of some kind? And then we can, that can even be used to train machine learning algorithms, for example. So, but one other, I mean, there might be an opportunity for a project for amateur astronomers to monitor nearby galaxies and then try to find supernovae. I mean, I know many of them already do this, so, but not really an organized effort, I don't think.
Yeah, right, exactly. And I know they do that too, so. So any other questions from the crowd tonight?
Could I ask two, please? One was wondering about how does the orbit of Earth around the sun, how does it affect some of the observations? And the other, I was wondering, when you mentioned about the fact that some of the lensing effect can be affected by black holes and other heavy matter from another galaxy. How does that affect, in some regards, some of the details in that? I was wondering, is that there have been some speculation about black holes or such having large mass items, basically interstellar or intergalactic. Has there been an attempt to using that for lensing effect? Thank you.
Yeah, interesting question. So I think the first question was, does Earth's motion around the sun affect observations of gravitational lenses? I think it actually does for galactic microlensing, where you have one star lensing another star. Then I think the Earth's motion actually does enter there as another parameter. So it's a good comment. And then I think the other question was, how do black holes enter into so yeah, I mean, so as I was showing in some of those figures, if some fraction, small fraction of dark matter consists of black holes, we should see their imprint on the light curves of these highly magnified stars. One thing I didn't mention is that a galaxy cluster actually exaggerates the size, effective size of the objects floating around in the cluster. And so they appear as if they're much more massive. They have a much bigger effect than they would be if they were just in empty space. So it becomes a very powerful tool of dark matter. And that's one connection. If people are looking for, through galactic microlensing, a population of black holes in our galaxy, but that's a somewhat different project. So.
Anyone else? So, Patrick, thank you. Thank you very much for coming and spending some time with us and opening our eyes to lensing is fabulous, and your other project. I mean, that whole turbo thing, I'm very excited about and anxious to watch and see if there's any possibility, because I'm an astrophotographer and I don't always need to take pictures of pretty things. I could always take a picture that's going to help science. So,
well,
that's
yeah,
an opportunity, and I know I don't speak. I'm not alone.
Yeah. Well, we get to image these really pretty nearby galaxies for the supernova search, so everyone should be happy.
Yeah, we can do that too.
I mean, if people are interested, I could potentially, we have people come over and look at the telescope sometime too. So just let me know.
All right, awesome. So thank you very much, everyone else. Hey, thank you for tuning in tonight, and we'll see you next month in a hybrid situation. So thanks again. Have a good night. Happy holidays, everyone.
Thank you.
Take care.
Take care.
Bye.